A very good evening to all of you. Myself Deepak Arora. So today we are going to discuss the most important concept with the super questions of the strength of material subject. Okay, so almost we have a 6 days. In the next 6 days we will discuss the concept of strength of material. Okay, so like all of you know, all of you are aware about that we have almost 7 to 8 chapters in a strength of material, and this is a common subject for mechanical as well as civil. Okay, so I will try to cover the questions either from the mechanical or from civil, from the both the. Very good evening, Mayank. Okay, so we'll try to cover the both the streams question as much as possible. Okay, so like, because some topics are important for the mechanical exam, some topics are important for the civil exam in a strength of material, so I will try to find the some balance and I will try to do that. Okay, so let's start with the subject strength of material. So today what we are going to do, today we are going to discuss the concept of the first chapter, simple stress and strain. First chapter, all of you are aware, simple stress and strain, and that's the most important chapter for whole strength of material. Why I am saying this is most important chapter? Maybe you will find the questions will be less in the exams, in the civil engineering especially, but in the mechanical engineering you will find a lot of questions from the first chapter, simple stress and strain. And the important part is the questions are really very easy from this chapter. Okay, mostly you will see the questions are maximum time the formula based. If you know the formulas of the questions, then you can solve the questions very easily. Okay, so let's start with the simple stress and strain. Okay, let's start with the first chapter, simple stress and strain, and day by day we'll cover the. Tomorrow we'll do the SFD, BMD, then bending stress, shear stress, then we'll cover the slope deflection, torsion, analysis of stress and strain, theory of failures. All topics I will complete and will try to make this much possible कि after 5 day or 6 day you will able to solve all the questions related to the strength of material. Okay, no, all questions are not possible, but maximum questions we will try to solve in next 5 to 6 days, so that will be helpful for you the upcoming GATE exam. Okay, all right guys, so let's start with the first chapter, simple stress and strain. So here you see we have two words in the chapter. One is stress, one is strain. We have two words, stress and strain. Let's understand this. What is stress? What is strain? Okay, then we'll move to the questions of this. I'm not going in that much details. I'll just give the basic idea which is required for the exam, and we'll solve the questions on that. Okay, so stress word, I hope so you heard first time in your 11th standard. If you remember, we have in physics second book, we have first chapter. Okay, elasticity, there we studied about the stress first, and strain also we studied there, right? So what is stress? Anyone, what is stress? What is stress? I hope so all of you are aware about stress. I'm not asking any type of stress, I'm just asking you what is stress. I hope so all of you are aware stress is equals to, stress we usually denote with sigma, and we say stress is equals to force per unit area. Stress is equals to force per unit area. But here if you see, let us suppose I have one bar and it is subjected to some load P here. Okay, and cross section area of the bar is, let us say, A. And if I ask you here, you will say stress is equals to P upon A. You will say it's a P upon A. But you notice one thing here, beta, this P force is the external force. This P force is my external force. So stress is not external force per unit area. Stress is internal force per unit area. What does it mean? Just see here. If here force P is applied, so can you tell me what will be the reaction on this support? What will be the reaction on this support? On this support, the reaction will be, you know, Newton's third law of motion, it will be equal and opposite. So here the force will be again P. Here the force will be again P, equal and opposite. If I cut one section here, it will be like that. Let us say this is part 1 and this is part 2. So this is part 1, this is part 2. Okay, so here P is there, and here due to this P reaction have been generated, here P is there. Okay, so now if you try to balance the equilibrium of part 1 and part 2, okay, let's consider part 1 first. On part 1, left hand side, how much force is there? The force is P. Now according to Newton's third law, again, how much force would come on this phase? How much force would come on this phase? On this phase also the force will come P. Similarly, same concept if you apply on the right hand side, here P is there on the right hand phase, left how much it will come? Again it will come here P. So stress developed due to this force P, not due to the external force P. Okay, stress developed always due to this internal force P. So what force I am writing P? This is my internal force, not is the external force. So stress is our internal force by area. Which area? Cross section area. Which area? Cross section area. Okay, so that's the difference between stress and pressure. I hope so all of you are aware. Pressure also you say pressure is force per unit area. So that's the basic difference between the stress and pressure. Stress is internal force per unit area, pressure is external force per unit area. Okay, stress is internal force per unit area and pressure is external force per unit area. Okay, so don't be mixed with these two words. Stress is different quantity, stress is internal quantity, pressure is external quantity. Okay, because it's due to the external force, it's due to the internal force. This is the basic difference between stress and pressure here. Okay, similarly, and one more thing here now. Let us suppose I have one bar. Now I applied the force P here. Now if I cut the section here, can you tell me what will be the stress at section XX? What will be the stress at section XX? What will the stress at section XX in this case? You can notice one thing here. In the previous diagram, I have restrained the one end, but in this diagram, I am not restraining the other end of this bar. Okay, if bar is not restrained, can you tell me what will the stress at section XX? Can you tell me what will the stress at section XX? What is the stress at section XX? Anyone? What will the stress at section XX? Here if you notice, there is no restraint, it means there will be no resistive force. Here there will be no resistive force. Okay, so due to that, if no resistive force is there, it means no internal force will be there. Stress will be 0 in this case. Okay, stress will be 0 in this case. Stress will only come when something is there which is restraining the movement of the bar or movement of the body, then only the stress will develop. Other than that, stress will not develop in the bar. Okay, so here it will be 0. So this is a basic definition of stress. Sigma is equals to P upon A. One thing you notice here, stress depends upon only the load and cross section area. Stress is not depending upon the material property at all. Stress is depending upon only the load and area, nothing else. Only which area? Cross section area. So stress depends upon only the two things. One is load, one is cross section area. Alright, okay. So this is my P upon A. So now can you tell me what is strain? I hope so all of you are aware strain. What is strain? Strain, all of you are aware what is strain? All of you are aware what is strain? Strain is our change in dimension to original dimension. Okay, it's not change in length. Okay, most of the time we say it's a change in length. No beta, it can be change in diameter also, it can be change in any dimension. So change in dimension to original dimension is called as strain. Okay, strain is equals to change in dimension to original dimension. Change in dimension to original dimension. This is called as strain. Okay. Now I will discuss about that. What are the types of stress and strain? I will come to that. But if strain is there, Like we say, if I applied the load P here, definitely due to this load P, the bar will deform. Due to this load P, the bar will deform, right? Then only the stress is generating. Okay, if bar will not deform, there will be no stress. If bar is not deforming, there is no stress. Like this case is there, bhai. This case is like your body is there. Okay, I have not restrained, somebody have not took your hand, you are free. I came, I took your one hand, I am pulling you. Will you feel any pain? Will you feel any pain in this case? If you are standing like that, I came from this side, okay, and I am pulling you. Will you feel any pain? Will you feel any pain? You will not at all feel any pain, okay, you will not at all feel any pain. It means what, beta? That there will be no stress. There will be no stress. Stress is nothing but it's a pain. If pain is happening, stress will develop. If pain is not happening, just apply the same thing on your human body. If you are feeling the pain, stress will develop. If you are not feeling the pain, stress will not develop. So if you see this case, here the definitely, because the motion have been restricted by this support, definitely the stress will be there. Here the movement is not restricted, definitely stress will be 0 in this case. Okay, so strain is there, then only the stress will generate. If strain is not there, stress is not going to generate. Okay, so this is basically stress and strain. Now if you come to the type of stress, if we discuss about the types of stress, basically we have two types of stress. One is normal stress, other one is tangential stress, or you may say it's a shear stress, tangential stress or shear stress. Okay, normal stress means which is acting normal to the cross section. Shear stress or tangential means which is acting parallel to the cross section. This is my shear stress. If normal to, let us say this is my section, if stress is like that, this is my normal stress. If stress is in my hand plane, this is my tangential stress. Okay, this is normal, this is tangential. Now if you come here, we have two types of normal stress. One is axial stress. Axial stress means due to axial load. Other one is we have bending stress. These are also known as direct or indirect. Okay, axial is known as direct stress. Bending stress is known as indirect stress. So axial stress, bending stress. Similarly, in the tangential also we have two types. What are the two types? One is direct shear stress. Direct shear means if you are applying the shear force directly, so it's a direct shear stress. Okay, like you have a ice cream brick. And with the help of knife you are cutting the ice cream. Then what happened? You are applying the shear force. Due to that force, which stress will develop? That stress will be the direct shear stress. Okay, that will be a direct shear stress. Second one we have indirect shear stress. Indirect shear stress means if this is your hand, okay, you came from this side and you took my hand and you are applying the torsion on my hand. Torsion means what? You are applying the moment along the longitudinal axis. If you apply the moment along the longitudinal axis, what will happen? My hand will twist. So due to this twist, the stress developed on the cross section edge, that is my indirect shear stress. Okay, due to torsion, the stress develops are indirect shear stress. So I am writing here, this is due to torsion. And bending stress you know, axial stress you know. Okay, similarly if I discuss about type of strain, if you have a doubt you can ask me in between any time. Okay, if you have any doubt you can ask me in between that. So types of strain. Similarly, in the types of strain, we have two types of strain. One is normal strain, other one is shear strain. One is normal strain, other one is shear strain. Again, normal strain means, just see, we have three types. Meaning is, if we have one bar, it is subjected to axial force P. Okay, then what will happen? Definitely this bar will deform. how this bar will deform? This bar will deform like that. This bar will deform like that. This bar will deform like that, meaning is this, previously area was this red line, now the area will reduce. So you can see the deformation is happening along the length also and along the cross section also. Okay, along the length also, along the cross section also. The strain developed in the direction of load is called as longitudinal strain. Okay, and along the perpendicular to the load, okay, that is called as lateral strain. That is called as lateral strain. Other than that, we have one more strain, that's the volumetric strain. That is volumetric strain. This is what? This is change in volume to the original volume. Longitudinal strain in the direction of length, lateral strain in the perpendicular direction of the load. You can see in this direction longitudinal strain, in the perpendicular direction this is my lateral strain. Okay, now this strain have no unit. Normal strain have a no units beta. Okay, normal strains have a no unit. Other than that we have a shear strain also. Other than that we have a shear strain also. What is shear strain? Shear strain will develop if shear force is there. Shear strain will develop if shear force is there. Let us suppose we have one block like that. We have one block like that and I apply the shear force like that on the. What is shear force? Shear force means in the plane I am applying the force. If I apply the shear force like that, then what will happen? This block will deform. This block will deform. How this block will deform? This block will deform like that. Okay, so now you can notice one thing. Previously, before the force applying, the angle between the block faces are 90 degree. You can see this angle was 90 degree. Now the angle is this. Now the angle is this. Yes or no? Yes or no? So this now what is shear strain? Shear strain is defined as only, shear strain is defined as initial angle minus final angle. Okay, initial angle minus final angle. This is the definition of shear strain. Okay, means previously you can see it's a 90 degree. Now that let us know some angle is there phi. Some angle is there that will be given to you in the question definitely. So this is 90, this is phi. Okay, this is 90 degree, this is phi now. So you can see here, what is the shear strain here? You can see initial angle is 90 degree, final angle is phi. So 90 minus phi is my shear strain. So you have to remember always it's a initial angle minus final angle. The question have come from this concept. But most important thing is we always say strain have a no units, strain have a no units. Only the normal strain have a no units. Shear strain is producing the angular deformation. So definitely shear strain have a unit. It will be the unit of angle. Okay, it can be a degree or it can be a radian. It depends upon the question. What question have given you? Either radian or degree. Okay, either radian or degree. What question have given you? That we have to consider here. Okay, so this is the basic introduction of this chapter. Simple stress. Stress two types, normal stress, shear stress, strain two types, normal strain, shear strain. Okay, basically in this chapter we are going to discuss about stress, axial stress. Okay, that is P upon A. Our complete focus in this chapter will be on a first stress, that will be a P upon A. Okay, we will discuss about the P upon A on. Hi Paran. Okay, so let's start the questions now. Whatever I discussed, I am solving some question on this. It's looking very easy, right? It's looking very easy. So one formula is there, P upon A, and here it's a strain it initial angle minus final angle. It's looking very easy. Okay, now see one question. Now see the question on this. See this question and try. See this question and try. All of you try this question. All of you try this question. What question is saying to us? The question is saying a bar of varying square cross section. एक मिस्टेक जो पॉसिबल एग्जाम में है ना, हम स्क्वायर की जगह सर्कुलर क्रॉस सेक्शन इतनी बार यूज करते हैं तो हमारी हैबिट बन जाती है एरिया ऑटोमेटिकली π/4 d स्क्वायर लिखने की. ठीक है, ये हैबिट बन जाती है क्योंकि हम ज्यादातर यूज जो करते हैं सर्कुलर बार करते हैं इन द होल कोर्स. ओके भाई, रीड द क्वेश्चन वेरी केयरफुली. अगर क्वेश्चन ढंग से पढ़ लिया ना, आधा क्वेश्चन तो वहीं से सॉल्व हो जाएगा. ठीक है, तो क्वेश्चन ढंग से पढ़ना बहुत इंपॉर्टेंट है. ओके, रीड द क्वेश्चन वेरी केयरफुली. ओके, ओनली फ्रॉम वन टाइम रीडिंग द क्वेश्चन द माइंड इन द माइंड फ्लो चार्ट मस्ट बी क्रिएटेड. हाँ भाई, इससे ये निकल जाएगा, इससे ये निकल जाएगा, इससे निकल जाएगा, लास्ट में आंसर आ जाएगा. अगर वो फ्लो चार्ट नहीं बनना क्वेश्चन पढ़ते टाइम इन द एग्जाम, तो भाई क्वेश्चन को थोड़ी देर के लिए छोड़ देना, मूव टू द नेक्स्ट क्वेश्चन. ओके, मगर फ्लो चार्ट बनना है कि हाँ भाई यहां से यहां, यहां से यहां, यहां से यहां, गो दी क्वेश्चन, सॉल्व एंड गेट द आंसर. अगर वो नहीं बन पाया तो समझ लो कि कुछ प्रॉब्लम है. ठीक है, चलो रीड क्वेश्चन पढ़ते हैं. A bar of varying square cross section is loaded symmetrically as shown in the figure. Okay, loads shown are placed one on the other axis of symmetry of the cross section. Ignoring the self weight, the maximum tensile stress in megapascal anywhere is. Question have not mentioned. You have to find the stress either any section. Question asks you what is the maximum tensile stress developed. What will the maximum tensile stress develop? You have to find here. Now Mayank have answered already 20. Mayank, just check again. Okay beta, so you can see here we have two blocks, 1 and 2. I am giving the name 1 and 2. Always if you see this type of problem, draw the free body diagrams. Okay, draw the free body diagrams. So I am considering these blocks like that. Let us say this is my block 2. Okay, and this is my block 1. This is my block 1. Now if you see on block 2, we have a two way to start the question, either from the top, either from the down, because when you draw the free body diagram, you have to start the free body diagram from one end. So here you can start either from top and from the bottom. I will suggest you to draw from the bottom, because on the bottom the force is known to you. How much force is there? 50. So let me draw here, it's a 50. So now for balancing the equilibrium of this block 2, how much force will come here? 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 Here the force will come again equal and opposite as per the Newton's third law. So here 50, here also it will be 50. Right. Now if you come to here, can you tell me how much force will come on the block 1? Can you tell me how much force will come on the block 1? How much force will come on block 1? Anyone? How much force will come on the block 1? Here it came 50. How much will come on block 1? Tell me fast. How much force will come on block 1? Anyone? How much force will come on block 1? सीधा कॉन्सेप्ट बता रहा हूं, एक ही बार में समझ लेना बेटा. जहां भी फोर्स निकालना हो ना जिस ब्लॉक में, उसके बीच में खड़े हो जाओ, उसके बीच में खड़े हो जाओ. अगर इसके बीच में खड़े हो गए तो उसकी जगह ऊपर देख लो या नीचे देख लो. मींस स्टैंड इन द बिटवीन द ब्लॉक, आइदर सी लेफ्ट और राइट, इट्स कंप्लीटली योर चॉइस. बट हियर यू सी, हियर इट्स नॉट लेफ्ट एंड राइट, हियर इट्स अ टॉप एंड बॉटम. ओके, इफ यू सी टॉप, it's a fixed support, no need to see because we don't know the force, right? If you see the bottom, here 50 was there, here 100 is there, here 100 is there. So total how much force is there on the top block? Total how much force is there? Total 250 kilonewton force is there. So here it's the force is 250 kilonewton. Now here 250 is there. For balancing the equilibrium of block 1, definitely 250 should come on the top also. Yes or no? We have to maintain the equilibrium of each and every part of the bar. Okay, so here 50, here 250. Now if I ask you sigma 1 and sigma 2, what is sigma 1, sigma 2? Sigma 1 is stress in block 1, sigma 2 is stress in block 2. So what is the force in block 1? You can see it's a 250 kilonewton. I am saying 10 to the power 3 because question asking me in megapascal. So I will convert into Newton per mm square. 250 into 10 to the power 3 upon area. What is the area of this block 1? You can see it's a 100, but it's a square cross section. So open the eyes very carefully. It will be 100. It will be 100 multiply with 100. Okay. So how much it will come? How much it will come? 4, 4. It will come 25 megapascal. It will come 25 megapascal. If you see the sigma 2, how much force is there in block 2? It's a 50. It's a kilonewton. So 50 into 10 to the power 3. Area is how much? It's a 50. So 50 into 50. How much it will come? How much it will come? How much it will come? Solve this first. How much it will come? How much it will come? Tell me first. It will come. It will come only 20 megapascal. It will come only 20 megapascal. Okay. So what is the maximum depth? Mayank, what is the maximum value out of this? What is the maximum value out of this? 25 or 20? Maximum. What is maximum? Maximum is our 25 megapascal. Okay. Maximum is our 25 megapascal. So this will be our answer of this question. Okay. This will be our option C is correct. Answer will be 25 megapascal. Only the concept which I want to tell you here. Draw the free body diagram very carefully. How to draw the free body diagram? Just stand in between the block or bar, whatever given to you. Either see top or the bottom. It's completely your choice. Okay. But we have to maintain the equilibrium at any cost. Okay. We have to maintain the equilibrium. Okay. So this will be the 25 megapascal will be the answer. Okay. Any doubt in this question? Anyone? Any doubt? Anyone? Any doubt? Anyone doubt? Alright guys, next question. Let's see the next question. All of you read the question. Options I am giving you in this question. Okay. Options I am giving you. The options are P upon A E1 minus E2 upon E1 plus E2. Option B is P upon A E1 plus E2 upon E1 minus E2. Option C is P upon A E2 by E1. Option D is P upon A. Okay. Yeah, Mayank, that's why I said to you, beta. Okay. It's not circular, the section was square. We have a mentality, we take the circular this much time in the whole engineering. So pi by 4 d square will be set in our mind. Okay. Blindly cross section is not given, we will assume. Right? We will assume it will be a circular. Like, I've got the best example. If anywhere in any question angle will be not given to you, always you take your favorite angle. Okay, without any logic, you always consider the angle is 45 degree. क्यों? लग रहा होता ना 45 सर लग रहा है, right? So we feel like it's a 45 degree because that's our favorite angle, right? If we don't know answer, our most favorite option will be 45 degree always, right? So it's not like that. Apply the concept. Definitely if it's 45, 45 will come with the mathematics. If it's not coming, definitely something else. Okay. Now read this question and tell me the answer. It's a very good question. It's a very good question. Tell me first. What question is saying? A rod of length L having uniform cross section area A is subjected to tensile force P as shown in the figure. Okay. If the Young's modulus of the material varies from E1 to E2 along the length linearly, the normal stress developed at section SS. Okay, there is one section at the mid length L by 2 and they are asking to us what will be the stress developed at there. Okay, what will be the stress developed there? So anyone tell me what will be the answer of this question? Which option is correct? Which option is correct? Question is saying the Young's modulus is varying from E1 to E2. Here Young's modulus is E1, here it's a E2. Let us say it's a linearly varying, okay? It's a linearly varying E1 to E2. So can you tell me what will the stress at section SS? Just now I told you here, if you see, I told you here, stress is P upon A. What is stress? Stress is P upon A. It means stress depend upon only the load and area. Stress doesn't depend upon anything else. What is E? Question is saying to you, E is varying from one to another end. E is varying from one end to another end. Bhai, I don't care, yaar. E is what? E is my material property. My stress depend upon only two things. One is load, one is the cross section area. Is it changing? Is it changing in step? Is it changing? Load is changing from this to this end, or area is changing from this to this end? No. Question is saying it's a uniform area. Okay, means area is A everywhere. If here load is P, here it's P. Definitely load is P along the bar also. So what will the option here? Blindly, answer will be here. Option D is correct. P upon A. You can see the very confusing options are given to you in the exam. This is a previous gate year problem only. Okay, options are given to you very confusing. Okay, and most of the chances are we will multiply definitely E1 and E2 somewhere in the question, because it happens in the exam, right? It happens in the exam. That's why I'm saying to you. Okay, so beta, stress depend upon only and only load and cross section area. So it will be P upon A. If P or A is changing, definitely my stress will change. But if P or A is not changing, my stress will be not changing. Stress will be a constant on the, if this section, if I ask you, this section I asked you, stress will be P upon A at all these sections. Okay, stress will not depend upon the material property E1 or E2. Okay, any doubt in this question? Anyone, any doubt in this question? Anyone, any doubt? Anyone, any doubt? Anyone, any doubt? Anyone doubt? Let's see the next question. All of you try this question. All of you try. This is a pi by 2. Okay, this is pi by 2 plus 0.005. All of you try this problem. If you have any doubt, you can ask me. Okay, in between, if you have any doubt, you can ask me. Bhagyasiri. बेटा स्ट्रेन अगर निकालते तो क्वेश्चन हमें कुछ डेटा देता. ठीक है, अगर हम स्ट्रेन निकालते तो हमें क्वेश्चन उस तरीके से कुछ डेटा देता जो क्वेश्चन ने दिया नहीं है, तो स्ट्रेन का कोई मतलब नहीं बनता वहां पे. अच्छा, अगर स्ट्रेन बोलेगा तो चेंज इन लेंथ वगैरह कुछ तो देगा तुम्हें वहां पे, या कौन सी स्ट्रेन पूछ रहा है उसके अकॉर्डिंग कुछ डेटा देगा, बट क्वेश्चन इज साइलेंट अबाउट दोज थिंग्स. ओके, सो क्वेश्चन यू कैन नॉट कैलकुलेट स्ट्रेन इफ क्वेश्चन हैव नॉट गिवन यू एनीथिंग, राइट? Strain is also a change in length upon original length, right? Solve this question. Hi Dheeraj. All of you try this problem. In a material under state of plane strain means भाई थर्ड डायमेंशन ना बहुत पतली है यार, थर्ड डायमेंशन जो है बहुत छोटी है. ठीक है, प्लेन स्ट्रेन मींस थर्ड डायमेंशन विल बी इग्नोरेबल. ओके, ओनली वी विल टेक अबाउट द प्लेन मींस एक्स एंड वाई फेस, वाई जेड फेस, एक्स जेड फेस. वी आर टॉकिंग इन biaxial. Okay, we are talking either xy, yz, zx, any two axes. It's my plane. Okay, like plane we are seeing here, right? It's a one plane. Okay, if third dimension will be there, that's not the case of plane stress or plane strain. Plane means we are talking in a two direction only. It may be x, y, yz, zx, anything. So in a plane strain, a 10 into 10 mm square centered at a point get deformed as shown in the figure. कुछ स्क्वायर था, कुछ डिफॉर्म्ड शेप दे दी गई है यार. ठीक है, if the shear strain gamma xy at this point is expressed as 0.001 K in radian, beta shear strain have some units, okay, because gamma xy is shear strain, so in unit it's radian. The value of K is, the value of K is, anyone can tell me what is the value of K? All of you try. Just now I told you the concept. Open the eyes, open the mind and tell the answer. Answer fast. Shear strain. Question is asking, do you shear strain? It's the xy because it's the xy plane, so it's the gamma xy. Okay, so shear strain. Just now I told you what is shear strain. It's defined as initial angle. It's defined as initial angle minus final angle. Initial angle minus final angle. So if you see beta, before the deformation, this is the square. Before the deformation, this is the square. So what is the angle between the face? This is the angle. This is the initial angle between the face, that is 90 degree. That is 90 degree minus final angle. You can see question have given you this angle. Question have given you this angle. How much? Pi by 2 plus 0.0005. So this is my pi by 2 plus 0.0005. Okay, but this is in radian given to you beta. This is 90 degree. 90 degree in radian will be how much? It will be again pi by 2. It will be pi by 2. So minus pi by 2 plus 0.0005. So pi by 2 cancel. How much will come? Minus 0.005. It will come minus 0.005. So you can see question have given you 0.0001 K. So what is the K value? What is the K value? Very good, Bhagyashree. What is the K value here? K value will be beta how much? K value will be here minus 0.5. You can see. Okay, K value will be minus 0.5. So क्या याद रखना है अपनों को याद रखना है बेटा, shear strain जो है वो है डिफरेंस बिटवीन इनिशियल माइनस फाइनल. बदल मत देना, ठीक है, चेंज मत कर देना. फाइनल माइनस इनिशियल नहीं है, इनिशियल माइनस फाइनल है, ठीक है. बिकॉज व्हाट इज स्ट्रेन जनरली? Change in dimension, right? It's a change in dimension to original dimension, right? So it's the initial angle was this, final angle is this. So it's the initial minus final angle. Okay, it's the initial minus final angle. Always don't say final minus initial. अगर final minus initial लिख दोगे ना बेटा, तो यहाँ पे प्लस 0.5 आ जाएगा जो गलत हो जाएगा, ठीक है. वो प्लस 0.5 आ जाएगा तो गलत हो जाएगा. इनिशियल माइनस फाइनल ध्यान रखना इस चीज पे, ठीक है. चलो नेक्स्ट क्वेश्चन पे आओ. एनी डाउट? एनीवन? Anyone doubt? Okay, next question. Okay, all of you try. All of you try. All of you try this problem now. Hello Rakesh. All of you try this problem. The value of true strain produced in a compressing a cylinder to half its original length is. Now you will say, sir, up to now you are saying stress, strain, but question is talking here about true strain. Okay, question is talking about here true strain. अब जब true strain है तो true stress भी होगा. जब true strain है, true stress भी होगा. Now here the thing is, in a civil engineering exam, the question have not come up to now related to the true stress and true strain concept. Okay, in the civil engineering exam, the question have not come from true stress and true strain, but I want to add one point here. The gate is touching the topic nowadays which have been not asked before. Okay, if you see the pattern of gate from the last few years, you will find that the topics are coming in the exam which have been never asked. Okay, that's why I'm focusing on this. If you see the IIT Kharagpur set the paper in 2006 and 2014, you see the strength of material questions are really good. Okay, in 2006 and 2014, the questions are really good. That's why I'm focusing more on the strength of material, because the questions level are really good in a paper when the IIT Kharagpur was organized at that time. Okay, so now see in this question, true stress, true strain. I am not going what the significance. Okay, दो फॉर्मूला है, याद रखो, सारे क्वेश्चन सॉल्व हो जाएंगे. ट्रू का मतलब नाम से ही बता सकते हो, ट्रू मींस रियलिटी. ट्रू इज ऑल्सो कॉल्ड एज एक्चुअल. ओके, because thing is this beta, when you apply the load on the bar, definitely the cross section area will be reduced. Okay, if you apply the tensile force, let me take the bar. If this bar is there, I apply the force P here. After the applying the load P, the bar will deform like that. Now previously area was this, now area have been reduced, but you always say it's a P upon A. You don't say it's a P upon initial area or P upon final area, because the area change is very less. Okay, the change in area is very less. So whatever we use for our purpose, that's called as engineering stress. Okay, that's called as engineering stress. We always use engineering stress for all our purpose. Why we are using? Because the difference is very less. Okay, that's the only logic. You can use the true stress also, but the measurement of that area, everything will be clumsy. That's why we use the engineering stress for all our engineering purpose. Okay, now here relationship is, you see beta, sigma T is equals to sigma E 1 plus epsilon E. T means true, E means engineering. Okay, true, T means true, E means engineering. So true stress is equals to engineering stress 1 plus engineering strain. This is the one relationship. True strain is equals to ln Li upon L naught. L naught is our initial length, Li is our instant length, instantaneous length, means after applying the load. Here length was L naught, here length was L naught. Now for one instant the load will be Li. Now you will say, sir, why are you saying instant? Bhai, my body is elastic. My body is elastic. After removing the load, the body will take its original position, but for one instant the length will be Li. For one instant that will be Li. I am talking about that instant, and for that instant we are calculating the true value. That's called that true stress or true strain. Okay, we are talking about that particular instant of true stress or true strain. So this is Li or L naught. Okay, so Li is our instant length, L naught is our initial length. Now here you can see in this derivation we assume one thing, what? The volume will always remain constant. So you can say here A naught L naught is equals to Ai Li. So you can replace here Ln, it can be written as A naught plus Ai, and this expression is also can be written as Ln 1 plus engineering strain. Okay, so this is my true strain formula that you have to remember. Okay, one formula you remember, rest formula you can write yourself. Okay, rest formula you can write yourself. Now tell the answer of this question. What question is saying? Question is saying to you, produce in a compressing a cylinder to half its original length. Initial length was how much? Initial length is how much? L naught, let us say. Now it have been compressed to, how much? L naught by 2. It have been compressed to L naught by 2. Put the value here. How much it will come? L naught by 2 by L naught. L naught to L naught cancel. It will come. Ln 1 by 2. Ln 1 by 2 value is how much? The value is minus 0.69. It means option B is correct. Okay, it means option B is correct. कोई भी क्वेश्चन हो ट्रू स्ट्रेस ट्रू स्ट्रेन का बेटा इन फॉर्मूलों से खत्म हो जाएगा. ठीक है, कोई भी क्वेश्चन हो ट्रू स्ट्रेस ट्रू स्ट्रेन का इन फॉर्मूलों से खत्म हो जाएगा, और दिमाग लगाना ही नहीं है. ठीक है, बस खाली ये याद रखना है, जो स्ट्रेस तुम हमेशा पढ़ते हो वो कौन सा स्ट्रेस है? वो है इंजीनियरिंग स्ट्रेस. ठीक है, वो कौन सा स्ट्रेस है? वो अपना इंजीनियरिंग स्ट्रेस. क्यों इंजीनियरिंग है यार? सब इंजीनियरिंग पर्पस के लिए हम उसे यूज करते हैं. इसे यूज करना है कर लो यार, कोई दिक्कत नहीं है. ऐसे कोई खास डिफरेंस है नहीं ट्रू और इंजीनियरिंग स्ट्रेस में. ओके, दैट्स व्हाई यू कैन यूज आइदर ट्रू स्ट्रेस और इंजीनियरिंग स्ट्रेस. Okay, but for all engineering purpose we use the engineering stress, because measurement of the smaller change is difficult. Okay, measurement of the smaller change is difficult, that's why I use the. Okay Dheeraj, okay, let's solve one more question on this concept. Tell the answer fast. Tell the answer fast. All of you tell the answer fast. All of you tell the answer fast. अभी बताया फॉर्मूला, अभी बताया फॉर्मूला. What question is saying? Engineering strain of a mild steel sample recorded at 0.1%. Okay, what is given to you? Engineering strain. So epsilon E is given to you 0.1%. Okay, what question is asking to you? The true strain will be. Mayank, open the eyes, beta. True strain is equals to, it's a 0.1%. Okay, true strain is equals to, just now you see I gave the expression here. Engineering strain, true strain is equals to ln 1 plus engineering strain. ln 1 plus engineering strain. So here it will be ln 1 plus engineering strain. Engineering strain is how much? 1.1%. 0.1% will be how much? 0.1 by 100. So 0.1 into 10 to the power minus 2. So tell me how much it's coming. It's asking to you again in percentage. So multiply with 100. Multiply with 100. So how much it's coming? Tell me fast. How much it's coming? How much it's coming? 0. KTK, just check again calculation beta. ln 1 plus 0.1 into 10 to the power minus 2 into 100. Why I am doing 100 again? Because question asking to me answer in a percentage. Okay, so how much it's coming? It's coming 0. Very good, Bhagyashree. Dheeraj, tell fast. 0.099. Answer is coming 0.099. Okay, answer is coming here 0.099. So you can see it's a one line question. It will not take more than 10 seconds if you know. This question have come various times in the exam. Okay, the question of true stress, true strains are completely based on these formula. Okay, whatever questions are coming, by this the question will be over. But only remember, true stress is based on the instant area. Engineering stress is based on the initial area. Okay, so this is our true stress and true strain concept. This is our true stress and true strain concept. Okay, now the next concept is, anyone doubt? Anyone doubt in these concept? Up to now we have discussed stress, strain, true stress, true strain. These four things we have covered. Very good, KTK. 0.099 and percentage. Okay, 0.099 in percentage. Anyone doubt? Shall I go ahead? Shall I go ahead? Anyone doubt? Anyone doubt? Alright guys, next question. Sorry, next topic which is important. Okay, just see the logic. Just see the logic. That is reloading of material. That is reloading of material. That is reloading of material. What is reloading of material? What is reloading of material? Reloading means once you apply the load, after if you are removing the load, how the material is behaving. Okay, that's called as, one is loading, you are applying the load. Reloading means you are removing the load, now how the material is behaving. Okay, now see here beta, here two things are there. Here two things are there. What are two things? One thing is if the loading is under elastic region. One other thing is if loading is beyond the elastic region. See very carefully, very important concept. So let me discuss first in elastic region. First one, case 1 is loading is in elastic zone or elastic region. Okay, so see here, this is my strain on x-axis and stress is there on y-axis. Okay, so now we have any curve, stress strain curve. Okay, don't think always a stress strain curve will be linear. Okay, Don't think always stress strain curve will be linear. It can be non-linear also. Okay. So let us say for this any material is there, the curve is like that, and here this point is E. Let us say, what is E point? This E is my elastic limit. This E is my elastic limit. I have one curve of stress strain curve, and E is my elastic limit. Curve can be linear, non-linear. It depends upon the material. Because we studied about the mild steel, it comes linear in the elastic zone. So we make a mentality for all the material, the curve is linear. It's not like that. Okay, it's not like that. It can be linear, it can be non-linear. Okay, but important thing is the loading is done under the elastic zone. If loading is done under elastic zone, then the loading end, this is my loading, so curve is coming like that. The curve is coming like that, means this curve is coming. If you remove the load, definitely the reloading curve will be same. It means the curve will go in the same path, curve will follow the same path. Okay, the most important thing is here, if loading is done under elastic zone. But case 2, if loading is beyond elastic zone, if loading is beyond elastic zone, let us say we have a stress strain curve. Here is a strain, here we have stress. Okay, and this is the curve. This is my elastic limit. Let us say this is my elastic limit. Now if the loading is done beyond the elastic limit, okay, like this is my loading curve, this is my loading curve. If loading is done beyond the E limit, if loading is done beyond the elastic limit, then beta stress strain curve will not be a same. Okay, stress strain curve will not be a same. The reloading curve will come somehow like that. But most important thing is here, the initial slope for the loading and unloading curve will be same. It means whatever angle will be there here theta, same angle will be here theta. Okay, the initial slope will always same, either it's a loading under the elastic limit or beyond the elastic limit. That's the most important concept. Now here you see, here the loading and loading in a same, so whatever deformation is there, that will be a elastic deformation, that will be a elastic deformation only. But here you see the loading and unloading curves are not same, means up to this you apply the load, when you remove the load, curve came here. It means you can see after removing the load, this is the strain here, this is the strain here, this strain is there. It means what? It means what? This deformation is my permanent deformation. This is my permanent deformation. It means this is called as plastic strain. This is called as plastic strain. This is also called as permanent set. This is called as permanent set. So what is the concept, beta? The concept is if loading is done beyond the elastic limit, then unloading and the loading curve will be different, but important thing is the initial slope for both the curve will be same. Okay, initial slope for both the curve will be same, and if loading is beyond the elastic zone, definitely there will be some plastic strain. Plastic strain means permanent strain, or plastic strain means what? Permanent deformation will be there. Okay, so this is my plastic strain and this is my elastic strain. Okay, this is my plastic strain and this is my elastic strain. This is my elastic strain and this is my plastic strain, beta. Okay, the question have come in a mechanical many times from this concept. Okay, what is the concept? Only two things you have to remember. If loading is beyond the elastic limit, initial slope will be same. One thing, initial slope will be same, and definitely there will be some permanent set. Okay, because the curve is starting from here, after unloading the curve is not reaching that point, curve has stopped before that. It means some strain is there, that's called as plastic strain or permanent strain. Let's see the question on this concept now. All of you try this problem. 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 It's very easy. Just now I told you the concept that you see the loading and unloading curve is different. It means automatically you can say if loading and unloading curve is different, it means automatically you can say the loading is done beyond the elastic limit. Okay, the loading is done beyond the elastic limit. Okay, tell me what is the answer here? Tell me what is the answer here? Here it's the stress. Okay, it's not written on y-axis. It's a stress, and here it's a strain. So which option is correct? Tell me which option is correct. Tell me which option is correct. B. Okay, okay, okay. The question is asking to you elastic and plastic strains are, okay, elastic and plastic strains are up to 200 megapascal stress. Okay, all of you try. Bhagyasri D. Okay, Mayank beta, just check. It's a elastic and plastic. So first one is elastic strain, second one is plastic. First one is elastic, second one is plastic. Okay. So which option is correct here? You can see beta, up to this loading happen. After that the load have been removed, the curve have been followed this path. It means up to now the curve have been reached. So what is this? This is my permanent strain. This is my permanent strain or plastic strain. That is how much? 0.01. 0.01. You can see what is the total strain. Total is 0.03. So what will be this? What will be this? This will be 0.02. So elastic is 0.02, plastic is 0.01. So which option is correct here? Option D is correct, not option B. Okay. Option D is correct, not option B. Okay. And one more thing here, question I have not given you. Maybe the question may come in the exam in such a way. Here angle will be same. Okay, whatever slopes are there, initial slope will be same. Why I am focusing on slope beta here? The slope of stress strain curve gives what? The slope of initial stress strain curve gives what quantity? Which quantity you will get to know? What the stress strain curve slope represents? Like if you know the mild steel stress strain curve, it will be, the stress strain curve of mild steel will be like that. So what is the slope of this straight line represents? The slope of this straight line represents what? The slope of this straight line represents, the slope of this straight line represents what? Modulus of elasticity. Okay, that's why this concept become very important. In the mechanical, the question have come already. Okay, the slope of a stress strain curve is the modulus of elasticity beta. So that you have to take care. It may be the question comes in the exam in such a way, you have to find the modulus of elasticity. The question have come in a mechanical, you can check. Okay, so E will be slope of stress strain curve. Of in linear portion or initial linear portion. Okay, so take care about this concept. It can be used in the exams. Okay, all right. Next topic is elastic constant. Next topic is elastic constant. Next topic is elastic constants. What is elastic constant? I hope so all of you are aware. We have a 4 elastic constants. One is E, that is our Young's modulus. Other one is G. Okay, next is K, and last one is mu. Okay, maybe you denote with 1 by m also in your time. Okay, so E is our Young's modulus. That will be derived with the help of Hooke's law. I hope so all of you are aware about the Hooke's law. What is Hooke's law? Hooke's law is normal stress or axial stress directly proportional to strain, axial strain. So stress is directly proportional to strain. Which stress here? It's a normal stress here. Okay, so normal stress by normal strain is our Young's modulus. So E is our normal stress by normal strain. G is our shear modulus. G is our shear modulus. That is what? That is what? That will be shear stress directly proportional to shear strain. Okay, so that will be tau is directly proportional to gamma or phi, whatever you denote. Okay, so tau is our shear stress, phi is our shear strain. So G is equals to tau upon phi. Next is K. K is what? K. K is our bulk modulus. It defined only for hydrostatic loading. It defined only for hydrostatic loading. What is hydrostatic loading? What is hydrostatic? Hydro. By the name only you can tell. Hydro means if any molecules, if I take ball and I put in the water. You know one concept, the pressure will be same in all the direction. Here it's not pressure, here it will be a stress. Hydrostatic loading means if stress is developing on the body on the all around same, that's called as our hydrostatic case, hydrostatic loading case. It can be hydrostatic tension, it can be hydrostatic compression. It means it can be like that, means stress developed same, or it can be hydrostatic compression also. But stress will be same on all the phases. Stress will be same on all the phases. This stress is also known as volumetric stress. Okay, this is also known as volumetric stress. Also, you will say it's called a mean stress. Also, this volumetric stress is directly proportional to volumetric strain. So here K come, K is equals to sigma upon epsilon V. K is equals to sigma upon epsilon V. What is epsilon V? Epsilon V is our volumetric strain, beta. Okay, epsilon V is our volumetric strain. Okay, but we remember it's defined only for hydrostatic case. Now, if I ask you here for incompressible body, can you tell me what will be the K value for incompressible body? This question will come in the exam very soon. Okay, for incompressible body, what will be the K value? What is the K value? What will the K value for incompressible body? What is the K value for incompressible body? Incompressible means what? The body will not compress. It means volumetric strain will be 0. If volumetric strain is 0, you can see K is equals to sigma upon epsilon V. Definitely K will be equals to infinite. Okay, K will be equals to infinite. If body is incompressible, bulk modulus will be infinite for that type of body. Very good, Bhagyasri. Okay, so we remember this. It can come in the exam. Last we have mu. Mu is what? Mu is our ratio of lateral strain, which I already told you, lateral strain divided by longitudinal strain. Okay, and here it will be a minus sign. Sometime you will see in a books it will be minus sign. Sometime you will see it's the modulus of lateral strain or longitudinal strain. Why this is the minus here? Common sense is there, beta. Here not a rocket science there. What is the common sense here? Bhai, if load is applied na, one dimension will increase, other dimension will decrease. That decrement have taken already in the formula, that is minus here. Okay, the decrement already have taken here, that will be a minus here. Okay, if you can say, sir, it can be the longitudinal minus also, it can be lateral minus also. Bhai, I don't know, yaar. If tensile load is there, so longitudinal strain will be positive because length will increase, diameter will reduce, that will be negative. But if compressive load, diameter will increase, so lateral will be positive, longitudinal will be negative. So it depends upon the question. So always we remember minus lateral strain upon a longitudinal strain, it will be automatically minus there, beta. But again, you don't take minus, okay? Again, don't consider the effect of decrement in the formula. Once we have already considered here lateral strain to a longitudinal strain. Okay, the mu value lies in between -1 to 0.5. Okay, but for our engineering purpose or engineering material, the mu value is 0.15 to 0.45. 0.15 is for concrete, 0.3 for a steel. Okay, and for elastic material, because our complete course is based on elastic material, mu value is 0.25 to 0.45. Mu value 0.25 to 0.45 for the elastic materials, beta. Like for a steel, the Poisson ratio is equals to 0.3. For a steel, Poisson ratio is equals to 0.3 beta. Okay. So 0.3 for a elastic for a steel, it can be 0.25 to 0.45. The range is this. Okay. So this is the elastic constant. We have some relationship between them also. Okay. Relationship between elastic constants are relationship between elastic constant so we have four constant E, G, K, mu. So relationships are E is equals to 2G into 1 plus mu, E is equals to 3K into 1 minus 2 mu, E is equals to 9 kg upon 3K plus G. Okay, it's like a 9 kg upon 3 kg. Okay, 9 kg upon 3 kg, 9K plus G upon 3K plus G, 9K plus G, 9 kg upon 3K plus G. Okay, so now one more is there in between the mu, but be remember only these two relationship. With the help of that you can derive any other two relationships also. Okay, so just remember top two, E is equals to 2G into 1 plus mu, E is equals to 3K into 1 minus 2 mu. Just remember these two expressions. With the help of that you can derive this also, and you can derive any other also. Okay, total 4 relationship you will find in the books, but be remember these two. All problems will be solved with the help of these two only. Okay, so E is equals to 2G into 1 plus mu, E is equals to 3K into 1 minus 2 mu. Okay, and for elastic material, for elastic homogeneous isotropic material, how many minimum constants are required for defining the homogeneous isotropic material? How many minimum constants are required? We need only two constants, because we know the relationship. If you know the two constants, other two constants can be found with the help of the relationship. Okay, so minimum two constants are required for defining the elastic homogeneous isotropic material. Only two constants are required beta. Okay, so be remember this question also have come in the exam. Two constants are required for that. It can be any two. It can be any two. It cannot be E or G, K or mu. No, it can be any two. If you know the two, other two can be found very easily. So be remember this concept. It will be helpful for you. Okay. And one more thing here I forgot. Mu value is maximum 0.5. Mu is equals to 0.5 for rubber. Okay. 0.5 for rubber and mu is 0 for cork. Mu is 0 for cork and maximum 0.5 for a rubber. Okay. Now if I ask you here, for incompressible material, can you tell me what is the mu value for incompressible material? The question have come in a mechanical as well as civil. Same question have been come in a mechanical as well as civil. For incompressible value, what material, what is the mu value for incompressible material? For incompressible material, what is the mu value? Just now we have seen beta, for incompressible material, K is equals to infinite. K is equals to infinite. If K is infinite, you can use the second relationship here. E is equals to 3K into 1 minus 2 mu. K is infinite, so E upon 3K, 3 into infinite is equals to 1 minus 2 mu. 1 by infinite how much? 1 by infinite will be, no, Bhagyashree, check again beta. 1 by infinite will be 0. 1 by infinite will be 0. So mu will come how much? 1 minus 2 mu is equals to 0. Mu will come 0.5. Okay, this question have been come in mechanical as well as civil. For incompressible material, the Poisson ratio is equals to 0.5 beta. Okay, so just see the one question on this. Just see one question on this concept now. All of you try this problem. It's very good problem. It's very good problem. All of you try. All of you try this. What question is saying? If EGK denotes Young's modulus, modulus of rigidity means shear modulus beta, and the bulk modulus respectively for elastic material, which one of the following can be possibly true? Okay, now just think and tell me which can be possibly true. Question is saying for elastic material, we have to deal with the elastic material. How will you solve this question? How will solve this question? How will solve this question? I am giving you, we know the relationship Eg equals to 2G into 1 plus mu. Okay, Eg equals to 2G into 1 plus mu. Okay. Okay, Iswar, can you check once better? E is equal to 2G into 1 plus mu. Let's consider B option only. Okay, if G is equals to E, if G is equals to E, so what it will be? It will be E is equals to 2E into 1 plus mu. E to E cancel. How much it will come? 1 by 2 is equals to 1 plus mu. Mu will be how much here? Mu will be 1 by 2 minus 1. It will be minus 0.5. It will be minus 0.5. For elastic material, is it possible the mu will be negative? For elastic material, it will possible the mu will be negative. I told you for elastic material, the mu value is 0.25 to 0.45. Here we are getting if E is equals to G, mu is minus 0.5. It means this option is not at all possible. Okay, if this is not possible, definitely this is also not possible because G is equals to E here. Okay, this is also not possible. Now just check with A or C. Just check A or C. Let me check with the C. If K is equals to E, let us say, you know E is equals to 3K into 1 minus 2 mu. Yes or no? You know E is equals to 3K 1 minus 2 mu. So E is equals to K. So E is equals to 3 1 minus 2 mu. E to E cancel. 1 by 3 is equals to 1 minus 2 mu. Can you tell me how much mu is coming here? Can you tell me how much mu is coming here? Can you tell me how much mu is coming here, Iswar? How much mu is coming here? Tell me first. 1 by 3 is equals to 1 minus 2 mu. So 1 minus 1 by 3, 2 by 3 is equals to 2 mu. How much it's coming? How much it's coming? How much mu is coming here? Bhagyasiri. How much mu is coming here? How much mu is coming here? If we solve here, 1 by 3 is equals to 1 minus 1 by 3, 2 by 3 is equals to 2 mu. So 2 to 2 cancel, it will come 0.33. You know, for elastic material, mu will lie in between 0.25 to 0.45. How much mu is coming here? 0.33. It means option C is correct. Okay, it means option C. Very good, Mayank. Very good, Bhagyasri. It means option C is correct. Anyone doubt? So how to approach the problem, beta? Question have given you here elastic material. For elastic material, you know only the mu value lie between 0.25 to 0.45. So just check with the trial and error method which relationship is going true. Okay, so you can see here option C is correct. Option B we found minus 0.5, which is not at all possible. If B is there, in D also it's a E, G equals to E. So D is also not possible. We have to see both options. Now you can see, sir, how you checked this. Beta, just a trial and error because I know this will come in the exam. It's your guess. You can start from option A also. You can start from option C also. It depends upon the guess only. Okay. So we cannot predict directly कि हाँ भाई option C will be there. Okay. So it's a trial and error method, right? Anyone doubt? Anyone doubt? Anyone doubt? Clear, beta? Clear? Everything clear? Alright. Next is our deformation of the bar. Next is our deformation of the bar. What is deformation means? I hope so all of you know Hooke's law. Meaning is, if we have one bar of length L, it is subjected to P load and cross section area is A, Young's modulus is E. What will be delta here? Delta will be equals to PL upon AE. Delta will be equals to PL upon A. I hope so all of you know. It's because of Hooke's law. It's because of Hooke's law. It's because of Hooke's law. Delta is equals to PL upon AE. But this is for prismatic. This is for prismatic section. Prismatic section means cross section is uniform. Okay, cross section is uniform. But if cross section is not uniform, it means the section is, let us say, tapered section. And which tapered? It's a circular tapered. Okay, it's a circular tapered. So what is the delta for this case? Again, let us say length is L. Here diameter is D1. Here diameter is D2. Okay, so delta is equals to, for in this case, PL upon pi by 4 D1 D2 into E. Okay, PL upon pi by 4 D1 D2 into E. Most of the time, what if you don't know the concept now, what you will do, you will say, sir, we will take the average diameter D1 plus D2 by 2 and you will solve PL upon E. You will apply this formula directly. Okay, this is the wrong beta. If circular tapered section is there, the formula is PL upon pi by 4, not D square, D1 D2. Okay, not D square, it's a D1 D2 into E. So this is the formula for a deformation of the bar. Only these two bars have been asked in the exam. Now you can ask me, sir, if multiple bars are there, like if this is a combination, it is a combination of bar, meaning here one bar is there, two bar, three bars are there, let us say. And if somebody asks you, what is the delta for this? If somebody asks you in the exam, what is the delta for this? So what is the delta? Delta will be equals to delta 1 plus delta 2 plus delta 3. Method of superposition you have to apply. Delta 1, delta 2, delta 3. Okay. So method of superposition you have to, whatever number of bars are given to you, just apply the method of superposition. Okay. Why you are applying the method of superposition? Because delta and P are both are linearly proportional, beta. Delta and P both are linearly proportional, then I am applying the method of superposition. We cannot apply method of superposition blindly anywhere. Okay, if relationship between delta and both quantity is linear, then only you can apply the method of superposition. Other than that, you cannot apply. Okay, so this is the question of deformation of the bar. Let's see one question on this concept. All of you try. All of you try. All of you try this problem. All of you try this problem. What question is saying? A tapered circular rod of diameter 20 mm to 10 mm is connected another uniform circular rod of 10 mm as shown in the figure. Okay, the both bars of same material with the modulus of elasticity 2 into 10 to the power 5. When subjected to P is equal to 30 pi kilonewton, the deformation at point A is, here it's my point A. Okay, here is my point A. Here this is our point A. So now you can see how many bars are there. How many bars are there? 2 bars are there. Let us say this is bar 1, this is bar 2. Just now I told you multiple bars are given to you. Delta is equals to delta 1 plus delta 2. Delta 1 is what? Delta 1 is our tapered bar. For tapered bar, what is our formula? For tapered bar, what is the formula? For tapered bar, formula is PL upon pi by 4 D1 D2 into E. Okay, second is delta 2. Delta 2 is our bar 2 is our prismatic bar. For prismatic bar, what is the formula? PL upon A. Okay, just put all the value in the formula, you will get the answer. P is how much? You can see if you draw the free body diagram of both the bars, this is my bottom bar. So here it's a 30 pi, here it's a 30 pi, definitely here also it will be 30 pi. Okay, and the top bar, it's like that. Okay, so here 30 pi is there, definitely this 30 pi will transfer to this bar, it will be like that 30 pi, and here it will be also 30 pi. So load is same on both the bar. Just put all the value in the formula. We take care, load is given to you in a kilonewton. Okay, load is given to you in a kilonewton. So convert into Newton. Convert into Newton. So 30 pi into 10 to the power 3. Length is how much? Length you can see it's a 2 meter. So 2000. Length is 2000 upon pi by 4 into d1 d2. d1 is how much? 20 into 10 into E. E is how much? 2 into 10 to the power 5. Okay. Plus PL upon E. P is how much? 30 pi into 10 to the power 3 into L is 2000 upon area is how much? Pi by 4. How much diameter here? 10 mm. So pi by 4, 10 square into 2 into 10 to the power 5. Okay. Just solve complete expression. You will get the answer of this question. Okay. It's very easy question. Only you can see it's a combination of circular tapered bar and the prismatic bar. So you have to apply the different formula for both the bar. You cannot apply the same formula. Okay. You have to apply different formula for both the bar. Can you tell me how much it's coming here? If you solve completely, the answer will come here 15 mm. Okay, answer will come here 15 mm. Okay, if you solve the complete calculation, answer will come here 15 mm. Okay, answer will come here 15 mm. Okay, so be remember the formula will not for tapered bar, it's a PL upon pi by 4 d1 d2. You cannot take d1 d2 by 2. If you do, you can see the answer will come some error. Okay, there will be some error will be there, and error will not be the minor error. Error will be almost 10%. Okay, almost 10% error will come if you take the average diameter. So don't take average diameter. Go with this concept, beta. Okay. Let's solve one more question on this concept. If you have a doubt, you can ask me. Mayank, we will be over in our next 5 to 8 minutes. It's a 1.5 hour class. Okay, so we started at 6 o'clock, 7:30 almost will end. One more thing I wanted to ask you, if you have any particular topic of strength of material you have a doubt, you can post here. I will take the more questions or of that topic. Okay, if you want a specific that topic, or you have a doubt in that topic specifically, you can message here, you can post in a chat box. So I will take that specifically that topic in the upcoming classes. Okay, whatever doubt you have in the strength of material, but after 6 days you must be in a position to solve all the questions. Okay, I know it's looking different in 6 days how we will cover the course of 70 hours. We'll try our best to make the course this much crispy. You will get the maximum in these next 5 to 6 days. Okay, all of you try. And Ankit sir is also taking the geotechnical class in a morning time. Okay, so join his class also for the geotechnical. Okay, Mayank, bending stress numerical. Definitely I will going to take bending stress. I am sure you are not talking the bending stress, maybe you are talking about the combined stress. In that axial plus bending both are there. Okay, so I will go through that definitely. Bending stress, it will be day after tomorrow, Mayank. Okay, tomorrow will complete the SFD, BMD and all these things. Okay, bending and shear stresses both we will take. If you have any doubt in any topic specifically, you can ask. So let's see, solve this question now. A horizontal bar fixed at one end has a length of 1 meter and cross section area 100 mm square. Its elastic modulus varies from along its length. Ex is equals to this. Okay, elastic modulus is varying, where x is the length coordinate in along the axis of the bar. An axial tensile load of 10 kN is applied to the free end at x is equals to 1. The axial deformation at the free end edge. So what question is saying? One bar is there which is fixed at one end, which is fixed at one end. Okay, and here it's a x is equals to 0 and here it's a x is equals to 1. Length of the bar is 1 meter. and you can see modulus of elasticity is varying for this bar. Ex is equals to 100 into e to the power minus x. 100 into e to the power minus x GPa is GPa, right? Modulus of elasticity is varying here, and it's subjected to load of 10 kilonewton. You can see load is applied 10 kilonewton. Question is asking to you, and area is also given to you 100 mm square. Area is given to you 100 mm square. Question is asking to you what will be the axial deformation for this bar. You know the formula, delta is equals to PL upon AE. But this is the formula when load is same along the length. Length means cross section area is uniform here, because area and tapered length is completely L. A is cross section area is same, but here you see E is not constant. E is varying from one end to another end. If E is varying from one end to another end, definitely we have to consider this. So what we will do, I am writing this formula as like that, beta. Px dx upon ax ex. If any quantity is varying, put the that function here, do the integration from one end to another end, from which point to another point it's varying, do the integration. So now you can see here delta is equals to Px. Load is varying with the x here. Load is varying. Here the load is 10. What is the load here? 10. Here load 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 10. It means load is constant. So I am taking P outside into dx upon a, area is also not varying, and E into x. It means what, beta? We are considering one small element here. We are considering one small element here at length x of thickness dx. Okay, we are considering one element of dx. Okay, so on, if I apply this formula on this dx element, so what is the formula? P into length is how much? Length is dx, area is constant. You can see area is here also for this strip will be 100 mm square, and E will be here 100 into e to the power minus x. So what I did, I am applying the same formula for this small element. So load is here, you can see 10 kilonewton. So 10 into 10 to the power 3. Why I am dealing with 10? Question is asking to you mm. So 10 into 10 to the power 3 into dx upon area is how much? 100 mm square into ex. It's a 100 into e to the power minus x. It's a GPa. It's a GPa. So if you want to convert into 100 e to the power minus x GPa, I want to convert into megapascal. So what you will do? Multiply with 10 to the power. Multiply with 10 to the power 3. If you do, it will convert Newton per mm square. Okay. So put the value here into 10 to the power 3. Limit will be here. Limit will be here 0 to x is varying from this end to another hand. So 0 to 1. If you solve this, you will get the answer here. Okay. You will get the answer here. Answer will come if you solve this completely. I am writing the answer directly. Okay. You can do the integration part here. It's very easy. Everything will be cancelled. Okay. Everything will be cancelled here. You can see. Okay. So in the last, answer will come here. You have to give the answer in mm. You have to give the answer in mm. Answer will come here E minus 1, or E value is how much, you know, 2.72 minus 1. Answer will come here 1.72 mm. Okay. Answer of this question will come 1.72 mm. Answer will be here 1.72 mm. But be remember this formula. If anything is varying, put the function of that formula in the exam. Sorry, put the function of that formula in this. Okay, and you will get the answer. My only point is, don't fear from the integration. Okay, don't fear from the integration. Like whatever formula you are applying for this complete length, I applied the same formula for a smaller part, that is a dx length only. Okay, we have to apply that formula on a dx length. So P into dx upon ax. Area is constant here also, here also, here also, here also, here also. Area is constant. A will be A and ex will be varying. So I put a ex value there. So you will, if you do the complete calculation, you will get the answer here 1.72 mm. Okay. Anyone doubt? Anyone doubt? Anyone doubt? Anything from your side? Anything from your side? Anyone? Anyone? Any doubt? If you have a specific any topic you want to ask me related to the strength of material, you can post in a chat box. I will take the questions on that topic. Okay, in upcoming classes. Okay, but I will take complete. I will not miss any single topic which is important for the exam. We'll cover all the topics which is important for the exam. Okay. Anyone doubt? You can ask me, guys. All right, guys. Then okay. All right. Alright, then see you tomorrow at the same time at 6 o'clock, and we will do the more questions tomorrow on a volumetric strain, thermal stress and shear force diagram and bending moment diagram. We will take those topics in the tomorrow class. Okay. Alright, thank you. Thanks for watching.